A, B, C, D, E and F are two sets of collinear points. Prove that AD parallel to CF. So let's take up the first cyclic quadrilateral. A, B, E, D is a cyclic quadrilateral because all the 4 points lie on the circle. So that's the first. A, B, E, D is cyclic. And by the properties of cyclic quadrilateral, we know angle 1 plus angle 2 will be equal to 180. So angle 1 plus angle 2 equal to 180. This is the opposite angles of cyclic quadrilateral are supplementary. Now we can see yet another cyclic quadrilateral, and that is BCFE. So we write that now. BCFE, they all lie on the circle. Hence this quadrilateral is cyclic. So which means now that I'll name this angle as 4. So I know angle 4 plus angle 3 equal to 180. Angle 4 plus angle 3 equal to 180. Reason? Opposite angles of cyclic are supplementary. Now we also know 2 plus 4 is 180. So 2 plus angle 4 is 180. That is a linear pair. Now if we compare both these, 1 plus 2 is 180 and we have 2 plus 4 is also 180. So I put equation 1, this is my equation 2. So angle 1 plus angle 2 equal to angle 2 plus angle 4 because both are 180. I cancel 2, so I have angle 1 equal to angle 4. This I'll put as equation 3. Now if you go back to this equation here, we know that angle 4 plus angle 3 was 180. But now we know angle 1 is equal to angle 4. So for angle 4 I am putting angle 1 plus angle 3 equal to 180. Now if 1 plus 3 is 180, if this is angle 1, angle 3 and angle 1 is 180, that means these two lines are parallel. So I can say AD is parallel to CF. So co-interior angles are supplementary. Therefore the lines are parallel. We go over it again. So we know angle 1 plus angle 2 was 180, was cyclic. So angle 1 plus angle 2, 180. Then we know this is linear pair. So this is 4. So angle 2 plus 4 equal to 180. And reason linear pair. So if I equate both these, I know angle 1 plus angle 2 equal to angle 2 plus angle 4. Both are 180, 180. I cancel angle 1 equal to angle 4. And in the next step, I know angle 4 plus angle 3 is 180. Same cyclic. But for angle 4, this is angle 4, I will put, this is angle 3. For 4 I'll put 1. This is 180. So these are co-interior angles and they're supplementary, so the lines are parallel. Here is a similar sum. So we have two triangles, two circles. Let us go to one. We know A, B, C, D is cyclic because all the 4 points lie on the circle. So we have A, B, C, D is cyclic. So we'll write quadrilateral. A, B, C, D is cyclic. Therefore, I can say angle 1 plus angle 3, 180. Angle 1 plus angle 3, 180. Opposite angles of cyclic are supplementary. I have yet another cyclic A, B, F, C. Let me draw that. So I have A, B, F, C. They all lie on the circle. All the 4 green points lie on the circle. So it is cyclic. So quadrilateral A, E, F, B is cyclic. So I can say angle 1 plus angle 2 is 180. So angle 1 plus angle 2, 180. So both these are 180. This is 180 and this also is 180. So I can say angle 1 plus angle 3 equal to angle 1 plus angle 2. This cancels out. Angle 3 equal to angle 2. Let me mark and see which is angle 2 and 3. This is angle 2 and here is angle 3. If 2 is equal to 3, these are corresponding angles. Hence I can say the lines are parallel. So I say these are corresponding angles. And if the corresponding angles are equal, the lines will be parallel. So I have EF parallel to DC. Before we go to this, there's a property we are going to use quite often. We have a circle, and in the circle, if we have a cyclic quadrilateral, this is the cyclic quadrilateral. This is the exterior angle. Now this exterior angle of cyclic quadrilateral is always equal to the interior opposite angles, because see, 1 and 2, we know angle 1 plus angle 2 is 180, and then here we have, say, this, right, 2 and 3, and we know 2 plus 3 is also 180. So we'll have angle 1 plus angle 2 equal to angle 2 plus angle 3. This cancels and I get 1 equal to 3. So remember, in cyclic, the exterior angle is always equal to this interior angle. So in this sum, in an isosceles triangle, AB equal to AC. Let me mark that. So we have AB here is AB equal to AC. If AB equal to AC, these base angles will be equal. I'll write them as angle 1 and angle 2. So let's write that first. AB equal to AC, and this is given. Therefore, angle 1 equal to angle 2. This is angles opposite equal sides. This is one part. Now we have a cyclic quadrilateral here, that is DECB. This is cyclic. Because the 4 points are on the circle. So if quadrilateral DECB is cyclic, which is a remote angle of this? Here is the remote angle, and this remote angle will be equal to the interior opposite angle, this angle. I will mark that as 3. So we have angle 2 equal to angle 3. This is property of cyclic. So here I have 1 equal to 2, and here I have 2 equal to 3. If I put them together, I'll have 1 equal to 2 and 2 equal to 3. So I have 1 equal to 3. Let's mark 1 and 3. This is 1 and this is 3. And these are corresponding angles, 1 and 3. Therefore, these two lines will be parallel. DE will be parallel to BC. So write these are corresponding angles. So since the corresponding angles are equal, the lines are parallel, that is DE parallel to BC. Here is given PQ and RS are two parallel chords. So we mark this, we have PQ is parallel to RS. If PQ is parallel to RS, the corresponding angles must be equal. So I'll mark this angle 1 equal to angle 2. So angle 1 equal to angle 2. So I'll write that now. PQ parallel to RS given. So angle 1 equal to angle 2, corresponding angles. And even this angle will be equal to this angle. So I'll have now 3 equal to 4. So angle 3 will be equal to angle 4 2. And the reason, corresponding angles. So these were the properties on parallel lines. But here we have a cyclic quadrilateral also. Now which is a cyclic quadrilateral? You have PQRS is cyclic. So here PQRS is cyclic. So PQRS cyclic. And then in a cyclic we know that the exterior angle is equal to the interior angle. So the exterior angle is 1. 1 is equal to 4. So we have angle 1 equal to angle 4. But earlier here we have already seen that 1 is also equal to angle 1 is also equal to angle 2. And angle 4 is also equal to angle 3. So if I take up 1 is equal to 4 and 4 equal to 3. Therefore I can say angle 3 equal to angle 1. If angle 3 equal to angle 1, OP equal to OQ, sides opposite equal angles. And I have proved. Let's go over it again. So I have these two lines parallel, and because these two lines are parallel, I can say these two angles are equal, and I mark them as angle 1 and angle 2, and on the other side we have these two angles equal, that is angle 3 equal to angle 4. But because of the property of cyclic, I now have 1 equal to 4. If 1 equal to 4 and 4 equal to 3, therefore 1 equal to 3. 1 equal to 3, these two sides will be equal. AB is the diameter of a circle. Angle A is 35 and angle Q is 25. Find angle PBR. So let's start with the diameter. AB's diameter. If AB's diameter, angle in the semicircle is 90, so this angle will be 90. So we have AB diameter. Therefore we have angle APB equal to 90. If APB equal to 90, on the other side this angle 2 will be 90 because it is a linear pair. This angle will be 90. Angle BPQ will also be 90 by linear pair. This, of course, the reason for this is angle in the semicircle. Angle in semicircle. Now if you notice, there are two triangles where two angles are given. Look at this triangle here, PBQ. In triangle PBQ, angle 1, angle 2, angle 3 equal to 180. We have 90 and 25 plus, say this is x, we do not know. So my x now is 65. So let me replace this with 65. So this angle is 65. Now here yet another triangle. I'm going to take triangle ABP. In this ABP also two angles are given. So I take angle APB. Three angles, you add up, you get 180. One angle is 35 here, one angle is 90, and I do not know this angle. I'll put this as y. So 35, 90 plus y, 180. So y will be 180 minus 125. So the y will be 55. Now if I want to find this angle, say A, I know the sum of this is 180. So A plus y plus 65 equal to 180. A I don't know, y I know is 55 plus 65 equal to 180. So A plus 120 equal to 180, and your A equal to 60. Then you can find all the other angles that they have asked you. AB and CD are two parallel chords. So let's mark it. These are parallel. AB, CD are parallel. So when they say AB parallel to CD, remember corresponding angles equal, alternate angles equal, whose diameter is AC. Prove that AB equal to CD. So let's mark the alternate angles. So this will be the alternate angles. Angle 1 will be equal to angle 2. So angle 1 equal to angle 2, that is alternate, because the lines are parallel. And here we also have 90 degrees. This angle and this angle is 90, equal to angle OMC equal to 90. So if we take up these two triangles, they are congruent. We need a third part, and that is OA equal to OC, because they're radii of the same circle. So we have OA equal to OC, radii of same circle. So the two triangles now are congruent. ALO triangle is congruent to OMC by AAS test. Triangle ALO congruent to triangle CML, that is by AAS test. If they're equal, then I can say by CP, CT, these two sides are equal. So LO equal to MO by CP, CT. So the distances are equal. These are the distances. So if therefore I can say AB equal to CD. Equidistant chords are equal. Equidistant chords are equal. Remember, this is the distance of the chord CD, and here is the distance of chord AB. If distances are equal, chords are equal. Two concentric circles with center O have A, B, C, D as points of intersection with line L as shown in the figure. AD is 12, BC is 8. Find the length of AB, CD, AC and BD. So let us take the outer circle. Here is our outer circle. Concentric circles are circles with the same center, and this is the chord. We'll call it the circle 1. So for circle 1, AD is chord, and here is a perpendicular. OM is perpendicular to AD. So you know perpendicular from the center bisects the chord. So I have these two sides are equal. So I can write AM equal to DM, and the reason, perpendicular from the center bisects the chord. So that was for the first circle. Now let's take up the second circle. So here is the second circle. For C2, BC is chord, and here is a perpendicular to the chord BC. So OM is perpendicular to BC. So it will bisect BC. So I can say here BM equal to CM, and the same reason, perpendicular from the center bisects the chord. Now earlier we have shown that AM equal to DM. So let's write that again. AM equal to DM. Now AM can be broken into two parts. If you look up in the figure, it's AB plus BM, and DM can be written as MC plus CD. But BM and CM are equal. Here we have BM, CM equal. So BM, CM I will cut. So what I am left with, AB equal to CD. This is one part, but we have to find the length of AB, CD and the BC. So first we had AD. So it was given to us that AD is 12 and here is a perpendicular from the center, and this perpendicular from the center divides it into two parts, one part and the second part. So we have AM will be equal to MD will be equal to half of 12, which is equal to 6. So we have AM equal to MD equal to 6. Next we have BC was given as 8. So BC equal to 8 centimeter. Here again the perpendicular bisects the chord. So we have BM equal to MC. So BM equal to MC, half of 8, which is equal to 4. So now this is, to go over it again, this was 8. So we have 4 here and we have 4 here. And this entire was, this was 6 still here, and this was another 6. Here 6 and 6. So definitely you agree that your AM, your AB will be 2 and your CD will also be 2. So our AB will be AM minus BM, which will be 6 minus 4, and that is 2, and CD will also be 2. So to go over this again, we have AM equal to MD equal to 6, BM equal to MC equal to 4, and AB equal to CD equal to 2 centimeters. PQ and RQ are chords equidistant from the center. If PQ and RQ are equidistant, we can say they are equal. Equidistant chords are equal. So we can say PQ equal to RQ. Reason: equidistant chords are equal. So this is first part. So I have these two are equal. Now we have the diameter. So we have angle P is 90 and angle R also will be 90. So since QS is a diameter, angle P equal to angle R equal to 90. And we have common QS is common, this QS is common. So QS equal to QS common. So the triangles are congruent by RHS. So triangle QPS is congruent to QRS by RHS. If they are equal by CPCT, I can say the angle PQR You can see these two angles, angle 1 equal to angle 2. So angle 1 equal to angle 2 by CPCT. So SQ bisects angle PQR. And on the other hand, I can say here 3 equal to 4, angle 3 equal to angle 4, CPCT. So SQ also bisects angle PSR. O is the center of the circle. Prove angle X equal to angle Y plus Z. So let us take up the first. Here I have X is a central angle, and this angle equal to half of, this is the angle at the circle. So I can say 3, angle 3 equal to X by 2. Similarly, angle 4 also, here is angle 4, this is angle 4, will also be, angle 4 will also be X by 2. That is, a central angle is always double the angle at the circle. So that's the first part. So if this is X by 2, let me write this here. This is X by 2 here, and this angle is also X by 2. So how much would this angle be? I'll mark this angle, say, as angle 5. So angle 5 will be 180 minus X by 2, linear pair. Similarly, on the other side, here I have another angle, that is here angle 6. So angle 6 will be also 180 minus X by 2, because they form a linear pair. Here we know that 3 and 5, they form a linear pair. Here 6 and 4, they form a linear pair. Now if this angle is Y, here too this angle will be Y. We call that angle as, say we call it angle 7. So angle 7 equal to angle Y, vertically opposite angles. Let us amplify this. We had this angle as X by 2, and this angle is also X by 2. Then by linear pair, we had this angle here as 180 minus X by 2. Similarly, here this angle also was 180 minus X by 2. This angle was Y, hence here this angle is also Y by vertically opposite angles. Now let's focus on this quadrilateral. Here we have the quadrilateral. We have we name it, maybe the names are not given here, so I'll just put this here as, say I'll put as P, and I'll put this Q and R. So for this quadrilateral, here this thick quadrilateral, it has got 4 angles, 1, 2, 3, 4, and equal to 360. And the angles are here 180 minus X by 2. 2 of them are 180 minus X by 2, Y plus this Z. This angle is Z, equal to 360. So we now work this out. 180 and 180, we get 360 minus X by 2 minus X by 2 plus Y plus Z equal to 360. 360, 360 cut out. So Y plus Z equal to X by 2 plus X by 2. So Y plus Z is 2X by 2. So this cuts out. So Y plus Z equal to X, and we have proved it. Let's just go over this again. Here we had this as X. Hence we got this angle this was x by 2. I had this angle. These are the four angles of the quadrilaterals. 180 minus x by 2. So here again we had x by 2. Therefore this angle here was 180 minus x by 2. So this is y. Here also y. Now in the quadrilateral, four angles. 1, 2, 3, 4 angles. These are the four angles, and you add up the four angles, you will get 360. So the four angles are 180 minus x by 2, one angle, 180 minus x by 2, the second angle, z, the third angle, and y equal to 360. This 360 and this cancels out. So minus x by 2 minus x by 2 plus z plus y is 0. So z plus y equal to x by 2 plus x by 2. Z plus y 2x by 2. So z plus y equal to x. So two circles whose centers are O and O dash intersect at P. Through P, a line parallel to O dash intersecting the circles C and D is drawn. Prove that CD equal to twice O dash. So first part, here is a chord, and here is a perpendicular to the chord, and the perpendicular to the chord bisects the chord. So the first thing I'll write AP equal to half of the chord CD. So this is for circle. We have CP is chord, and we know that OA is perpendicular to CP. Similarly on this side, here is the chord, and here we have a perpendicular. So we have here PD is chord, and the O dash B is perpendicular to PD, which means now it cuts it into two equal parts. So PB is half of PD. This is the first part. Now for the second part, we knew this was perpendicular. Here too also we had a perpendicular, and these two lines are parallel. If these lines are parallel, that means here also we will have perpendiculars. So we have AD parallel to O dash, and angle A equal to angle B equal to 90. Therefore co-interior angles are supplementary, so angle O will be equal to angle O dash will be also equal to 90. So we have OAB O dash is a rectangle. All the angles are 90. So here now we have a rectangle. Now in a rectangle, opposite sides are equal. That means AB equal to O dash, opposite sides equal. So, but our AB is made up of AP plus PB equal to O dash. Now what is AP? Here we know what is AP, half of CD. And what is PP? Half of PD equal to O dash. We take half common out. CD plus PD equal to O dash. So CD and PD you see is CD. Here is CP. This is not, should be half of CP. So I just rub this out. So this will be now half of CP, here half of CP. CP plus PD is CD. So CD equal to O dash. So CD is twice O dash. So here ABCD is a parallelogram. A circle through ABCD intersects CD produced at E. Prove AE equal to ED. So first we have a parallelogram. So AE BCD, this is a parallelogram. Hence I can say angle 1 plus angle 2 equal no, is 180. Angle 1 plus angle 2 is 180 because it is cyclic. It's not a parallelogram. A, B, C, C, E is cyclic. So first state, opposite angles are supplementary. Now I have a parallelogram, and that is A, D, C, B is a parallelogram. So opposite angles are equal. 2 equal to 3. So we have A, B, C, D is a parallelogram. So I put this as 3. So angle 2 equal to angle 3. Opposite angles equal of parallelogram. I have a linear pair. If I put this as 4, this is linear pair. So angle 3 plus angle 4, 180, and that is linear pair. Now I'll take two of them together. That is, I know this is 180 and here also is 180. So I get angle 1 plus angle 2 equal to angle 3 plus angle 4. But 2 and 3 are equal, so 2 and 3 I cut, because it's given here 2 equal to 3. So I get angle 1 equal to angle 4. Now if angle 1 is equal to angle 4, these two angles are equal, so I can say AE be equal to AD. Sides opposite equal angles. Sides opposite equal angles, and I proved. This was 1 and this is of course 4.